Welcome to lesson 3.2b vector worksheets. So today we're just going to be taking a look at some handouts, both for the warm-up and the lesson, and then some for homework, simply because the workbook that we use does not provide you adequate examples for this section. This leads us into getting ready for an upcoming quiz, so be ready for next class after to do a quiz. So let's just do this warm-up, and this warm-up compares the difference between distance and the displacement. All right, so it says here, complete your questions with a partner. I don't need you to have a partner. We'll just do it as a warm-up. So what we need to do is to verify from A to B. So A is our start and B is our end. All right, so the distance from A to B is I count my arrows. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 12 units of distance. However, my displacement is how many total have I gone, and that's going to be, so from here I've gone 1, 2, 3, 4 units. And remember, displacement has a direction, so that's 4 units right. Okay, let's take a look at the second example here. Again, for distance, we just count how many units we've moved. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 units that we've moved. Okay, and our displacement is, hey, how far from A to B have we gone? And if you count 1, 2, 3, 4, 5, 6, okay, we have 6 units, and of course we need a direction, which is left. Awesome. Next one, taking a look at going from A to B. If we take a look at our distance, again, we count the arrows, 1, 2, 3, 4, 5, 6, 7. Each arrow represents a box if you're not sure. That goes 7 units. However, if we try to calculate our displacement from A to B, we go 1, 2, 3 units down. Okay, 3 more here, guys. Taking a look at our distance, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. Okay. And our displacement is how far have we gone? We've gone 1, 2, 3, 4 units to the right. And this is just emphasizing the difference between a vector and a scalar. Remember that distance is scalar because it just has a magnitude, whereas displacement is a vector which has a magnitude and a direction. All right, 2 more here to finish this warm-up up. Oh, we got to get counting here. So the distance, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 units. Whereas our displacement is, let's count it, 1, 2, 3, 4. We've gone 4 units to the left. Or you can put 4 units left. I'll just fix that. We don't need 2 left. All right, last one, folks. Here we go. Let's count up the arrows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 units. And our displacement is from here, we go 1, 2, 3, 4 units up. So that should be a good review of the difference between scalar quantity and a vector quantity. All right, remember the vector quantity has a direction. All right, let's take a look at the next handout, which is the first part we're going to do in our lesson. So our lesson today is going to be the one worksheet that, shows me 5.71. These are taken from the TIPS binder, which often is a resource from the government that we use. Okay, so it says all vectors are not created equal. All right, complete the following statement. A vector is a quantity which has a magnitude, and direction. Remember, the scalar only has a magnitude. All right. Examine the vectors in the diagram. Classify the vectors in the table below with the appropriate vector notation. All right. So first of all, which ones have a magnitude only? Okay. So taking a look, do we have ones that have the same magnitude? Okay. So the same magnitude means they must be going the same amount of spaces. Okay. So for example, let's take a look at IJ. IJ, if I look at this one here, folks, IJ has the same magnitude as EF, because you notice the starting point to the end point is up to and to the left, or my fault, to the right 3. Okay, so we have IJ with an arrow on it, okay, and EF. Okay, so those have same magnitude. Do we see any others that match that case? Hopefully you'll notice AB is exactly the same. Okay, and CD is also the same. Okay, and looking at GH, GH is also the same. Okay, now magnitude only means we could also look at other aspects. If they're going the other direction, we could still use them. So take a look, everybody, at AM. So AM is also, oh, my fault, AM, not AB. Is also have the same magnitude because it's the same distance. Let's just double check there. Looks like we've got them all. Yep, good. Okay, same direction only. So let's start with IJ. I'll erase them so you can see. Okay, so same direction. Okay, so start with IJ. Okay, so with IJ, vector IJ, which ones match it? Well, CD matches that one. Okay, GH matches that one. Looking AB matches that one. Okay, which other ones go in the same direction? There's still a couple more. So taking a look, let's look at EF. EF is the same. That's one I'm missing. With an arrow above it. And I want you to notice also, looking at this, S and T and X and Y. Although they have different magnitudes, they have the same direction. So X and Y and S and T. All right. So now let's narrow in the same magnitude and direction. Okay. So which ones have the same magnitude and same direction? Okay. All right, so same magnitude and direction. Let's start with IJ. Basically, it's the ones that appear in both of these the same. So IJ is exactly the same as CD, which is exactly the same as EF, which is exactly the same as GB, and I believe the same as, is it AB? Let me just double check. AB, yeah. Okay, so those have the same magnitude and direction. However, do we have others that have the same magnitude and direction, but just aren't the same magnitude? So we're going to do a subsection here, and notice that there are two that have the same direction and magnitude, but are different than this original set that we have. So let's focus on X and Y. Okay, it has a different magnitude than different magnitude but same direction as ST. So X, Y, and ST are their own subcategories in there. Okay, which one of the bunch here, guys, has no similarities? So which vector here have we not chosen? And that's going to be QR. It's a little bit of a loner because it doesn't have any common quantities or directions, okay? All right. Good. All right, let's take a look at the next part. On the grid, construct a vector with the same magnitude as AM. Okay? So same magnitude doesn't mean exactly the same. So what I'm going to do is, hey, I'll just go 2 below it, for example. So A is here, M is here. Okay? So let's just make a new one. And why don't we call it KL? Okay? So on the grid, we're going to have KL. Okay, so it's got the same magnitude and direction. All we've done is we've just translated it down to units. Okay, you could have multiple examples there. I just chose to do it right there. All right, 4. Without measuring, how would you determine that AB and AC have equal magnitudes? Well, without taking a measuring tape out, you would take a look and see if it has the same units of rise and run. Okay, so same rise and run combination. Okay, but to the same units as the rise and the same units as the run. Right, last question before we get on with tonight's homework. AB and vector EF are an example of equal vectors. What conditions are necessary for equal vectors? Okay, so in order to be equal, first of all, you have to have the same magnitude. Sorry, magnitude. That's the same for scalar and vector. But what makes it equal vectors is that it has to have the direction as well. So same magnitude and same direction. So if we pop back up here, folks, all of these in this category of the red, so this is a group of equal vectors, and this is a subgroup of equal vectors. All right, so going to the bottom, ladies and gentlemen, it's more of a work period here. So our handouts are on the next pages. I'll show you in a second. And again, you're just filling in information. Please come see me if you need extra help. So you've got 1 handout here, 2, and 3. So 3 sheets just to get yourself familiarized with the difference between a vector and a scalar, drawing some diagrams, referring to compass bearing and conventional bearing. Just a bit of a review in there. Okay, so here's your homework. Have a good luck with that, and come see me if you need any help. Have a great day.